Hey everyone, today we're going over rationalizing with radicals. Before I start, there are 3 warm-ups that you should try before I go over them. 28, the largest perfect square that divides 28 is 4, and the square root of 4 is 2. So square root of 28 simplifies to 2 square root of 7. 3 square root of 18, well 18, the largest perfect square that divides 18 is 9. Now we get this extra 3 out front. Don't forget about the original 3 that was right there. And we multiply those numbers when they're outside of the radical. So we get 9 square root of 2. And finally, for this last one, remember we multiply the outsides. We multiply the insides. And then when you get 72 underneath the square roots, the largest perfect square that divides that is 36. So we get a 6 times 6 outside. So we get 36 times the square root of 2. So I guess I'll call it new stuff for today, is when we're doing problems that involve division and square roots. If you have a radical in the denominator of a fraction, in the bottom of a fraction, you must write this down, rationalize. What does it mean to rationalize? For something to be simplified, there can be no square roots, cube roots, any kind of roots in the denominator. So when we look at this first example, we have 5 divided by the square root of 2. I can't really do anything with the numbers 5 and 2. 1 is not in the square root, 1 is. And that square root in the bottom square root of 2 means that this is not simplified. So our way that we rationalize is we have to multiply the top and bottom by that square root that you see in the bottom. So 5 over square root of 2, how are we going to get rid of the square root in the bottom? We multiply by the square root of 2 on top and bottom. Can't really do much in the way of simplifying the top. It's just 5 times the square root of 2. Don't multiply the numbers together. It's not 10. It's not square root of 10. And on the bottom, when we do the square root of 2 times square root of 2, like we talked about yesterday, so square root of 4. And the square root of 4 is something that we can simplify. It doesn't have a square root anymore because the square root of 4 is 2. Now sometimes there'll be a little bit more to do here, but this is rationalized. 5 over square root of 2 we can rewrite as 5 square root of 2 over 2. And I know it doesn't look simpler, but we consider this in math to be simplified because there's no square root in the bottom. Be a good idea to try number 1 really quick on your own. If you're watching this on your own, you can pause it really quick and try it. But to see a solution, I see a square root of 7 in the bottom. So I know that I'll need to multiply top and bottom by the square root of 7, giving us 3 square root of 7 over the square root of 49, and hopefully you know that the square root of 49 is 7. Now, number 2 starts the same way, but there's a little extra to do for this one. We see the square root of 6 in the bottom. We have to rationalize, so we're going to multiply top and bottom by the square root of 6. So we get 4 square root of 6 on top, and then the square root of 36 on bottom, which simplifies to just 6. But in this case, you might notice something. The numbers that are not in the square roots, 4 on top, 6 on bottom, we can simplify that. Just like you would fraction without the square root of 6, 4 over 6. We can take a 2 out of both, which simplifies to 2/3. So we're going to do that same thing with this one. We're going to take a 2 out of the 4 and the 6, not out of the square root. So when we simplify the 4 and the 6, we get 2 square root of 6 over 3. You should now try 3 and 4 on your own. I'll put the answers right at the end, but just the answers. We're going to move on to number 5. What happens when we have more than one square root in the problem? Just because there's a square root on top doesn't change the fact that it's not simplified till we don't have any square roots in the bottom. We're going to take the same process. I'm going to multiply top and bottom by the square root of 2. The difference in this case is that on the top, since they're both square roots, we can multiply their insides. So we get the square root of 12 over the square root of 4, which equals the square root of 12 over 2. Now, the tough part about this one is that the square root of 12 isn't itself simplified. So we have to think about what we've done for the past 2 days, and we do have to simplify that radical on the top. You might recall, square root of 12, we could rewrite as square root of 4 times square root of 3, and we know that the square root of 4 is 2. And you will see in this case that the 2 in the numerator and denominator divide out to 1. So this one's answer is actually just the square root of 3, no fraction left over. Again, I'm going to say you should try number 6 on your own. I'll put the answer up at the end of the video, but I'm going to do one more, and then you can work on your homework. So for this last one, there's square root on top, and on the bottom there's a 3 square root of 6. Again, this is not any different, but it kind of feels different when doing this. This problem is not simplified because there is a square root in the bottom. And to get rid of the square root in the bottom, we just have to multiply by that square root that we see. I know we see this 3 in the bottom, but you don't need to consider that when trying to rationalize. When we rationalize number 7, we're just going to multiply top and bottom by the square root of 6, because that will help us get rid of the square root. Now this one has a lot of simplifying to do in the problem, so bear with me. 6 times 15, since they're both in square roots, that would be the square root of 90 on top. On bottom, don't forget about that 3. That 3 is still there, but then we have the square root of 6 times the square root of 6, which is the square root of 36. And then we can do some simplifying here. I'll start with the bottom. Square root of 90 on top. The square root of 36 is 6. And don't forget that that's multiplication in the denominator, so we get the square root of 90 over 18. Please remember to check the top square root, because the square root of 90 is able to be simplified. 90 is 9 times 10, 9 being the largest perfect square that we can divide out of 90. Square root of 9 is 3, so we get 3 square root of 10 over 18. And there's one more step we have to do. Look at those two numbers now that are not underneath the square roots. We got a 3 in the numerator and 18 in the denominator. You can divide a 3 out of both. And remember, that doesn't affect the 10. So we get 1 times the square root of 10 on top, so I'm not going to write the 1. And then when we take the 3 out of 18 on the bottom, we get over 6. So that's an explanation on how to rationalize denominators. The 3 remaining problems. Number 3, the answer should be 12 square root of 5 over 5. 4, let's see, you'll get 8 square root of 10 over 10, which should simplify to 4 square root of 10 over 5. Make sure you had the simplified form. And then finally, for number 6, you would get the square root of 60 over 6, which is 2 square root of 15 over 6, which equals the square root of 15 over 3. If you need a little bit more explanation for 3, 4, or 6, make sure to check the slides on the calendar. It has a little bit more work to kind of show you where all that stuff comes from. Have a good rest of your day, everybody.